let's put everything that we've done in the last couple of videos together and identify the oxidizing agent. In our reaction. To do this, we need to assign the oxidation numbers to everything that appears in the reaction. Let's do a simple example, and then we'll do a more complicated one. This is the reaction between methane, which is the main component of natural gas, and oxygen. This is what happens when you burn natural gas, mostly. You get carbon dioxide, and you get water. Don't worry too much about how I figured out how to write the equation down or how I knew what the products were. We're going to do all that later. I'm going to just say, here's the reaction. It's a combustion reaction. Something is burning, and whenever you have a combustion reaction, that is a reaction that involves oxygen here. That is an important class of redox reaction. So this is going to be a redox reaction, and we can actually see that by looking at where the electrons come from and where they go. We want to identify the oxidizing agent here. Now, I know the oxidizing agent will be either the methane, the CH4, or the O2. Now, probably you know right away that oxygen is the oxidizing agent, because that's what oxygen does. That's where the term oxidizing came from. But let's work it out. All right, the first thing that you need to do is assign oxidation numbers. And we have done that in the previous two videos. Let's do it. If I've got CH4, the rules are, rule 1, do you have only one element? No, we've got two elements. Rule 2 is, do you have an ionic compound with elemental ions inside of it? This is not an ionic compound. It's got two nonmetals. If it were ionic, we'd see a metal and a nonmetal. Rule 3 is, the oxidation numbers for all of the atoms that are in here have got to add up to the total charge. The total charge on this thing is 0. So I'll keep that in mind. All my oxidation numbers better add up to 0 in the end. The next rule says, do you have any fluorine? Nope, we don't. The next rule says, do you have any hydrogen? Yes, we do. There are 4 hydrogens in there. And that rule says if you got hydrogens in there at this point, you can give them an oxidation number of +1. So essentially what you have there are 4 hydrogens. Each one has got a +1 on it. Now, from rule 3, we know that all of the oxidation numbers, which are very much like charges, they're not really charges, but they act like charges. All the oxidation numbers have to add up to 0. Okay, well, if we've got +4, what has to balance that off? It has to be a -4. So that means that the oxidation number for the carbon here is going to be -4. And for the hydrogen here, it's going to be +1. That's for each of those 4 hydrogens, it'll be a +1. Okay, let's assign oxidation numbers to the next thing. Well, we've got an element here. There's nothing in there except oxygen. Rule 1 takes care of that right away. It says if you've got just an element, just one element, the oxidation number on that is 0. Okay, fine. Now, this one we did before. Let's do it again. Carbon dioxide. Let's figure out the oxidation numbers in here. Rule 1 says, do you have just one element? No, we don't. Rule 2 says, do you have an ionic compound with elemental ions in it? No, I don't. This is a covalent compound or a molecular compound because it's only nonmetals in here. So I go to Rule 3. Rule 3 says, the oxidation numbers for every atom in here have to add up to the total charge, which is 0. So the oxidation number of the carbon plus 2 times the oxidation number on the oxygen have to add up to 0. I'll keep that in mind. The next rule says, got any fluorine? No, we don't. The next rule says, got any hydrogen? No, we don't. And the final rule, the 6th rule, says, do you have any oxygen? Yes, we do. And it says that if you've got oxygen there at this point, you can assign an oxidation number of -2 to it. So we've got 2 of those in there. Each one has got an oxidation number of -2. Now, what does the charge on the carbon have to be so that the charges on all of these, the oxidation numbers, I should say, of all of these add up to 0? Well, this is a total of -4. So what does the charge on this have to be to balance it off? If you said +4, you're right, that works. +4 -2 -2 is 0, so that works. So we have the oxidation number for the carbon here is +4, and for the oxygen, it's -2. Now I could go on and do the oxidation numbers for this last one, and let's do that. But actually, I can answer the question from just what I've done so far. If I were an A student, I could stop here. But let's go ahead and assign the oxidation numbers for everything in here, just to be thorough. Okay, we want to assign oxidation numbers for the atoms that are in H2O. Rule 1, do I have only one element? No, I've got 2, hydrogen and oxygen. Rule 2, do you have an ionic compound with elemental ions in it? No, this is a molecular compound because it's got 2 nonmetals in it. Rule 3, all of the oxidation numbers need to add up to the total charge, which is a 0 in this case. I'll keep that in mind. The next rule says, got any fluorines? Nope. Got any hydrogens? Yes, we do. There's 2 hydrogens there, so I'm going to assign them next. That rule says if you've got hydrogens at this point, you can give them a +1. So essentially what I've got in there are 2 H pluses. Now, I know enough to assign the oxidation number on the oxygen, because Rule 3 told me that all of these have to add up to 0. +1 + 1 plus what equals 0? Or said another way, I have a total charge of +2 on both of these. So what does the charge on this have to be in order to balance those 2 off? If you said -2, you're right. So that's the oxidation number on the oxygen. Whoops. I'm going to put the oxidation number on each atom here, not on both of them together. So I should write each hydrogen has got a +1 and the oxygen has got a -2. Now, to find the oxidizing agent, I have to remember the definition of oxidizing agent. The oxidizing agent is the thing that causes oxidation. But the oxidizing agent itself gets reduced. So I can look at my oxidation numbers and look for where the reduction is. Where does the oxidation number go down? Okay, if I look at the carbon here, it starts at a -4, and on the other side it goes up to a +4. So we went up. The carbon got oxidized. To find the oxidizing agent, I'm looking for the thing that gets reduced. So let's look somewhere else. Let's look at the hydrogens. It starts off as a +1. The hydrogens on the other side all have a +1 as well. So it's not really involved in the electron transfer directly. So I'm going to go on. Let's look at the oxygen. It starts off with an oxidation number of 0, And then over here and over here, in both places, it goes down to -2. The oxidation number gets reduced. It goes down. So the thing whose oxidation number gets reduced is the oxidizing agent. And just like we suspected, the oxidizing agent here is O2 in this problem. All right, that's long enough. I'll do another example, if you like, in lecture. Let me know.